moving on to the next topic is formation of sedimentary rocks. Okay, now compared to igneous rocks, sedimentary rocks are a little more complicated because it is formed from sediments, and sediments can be of different types. You have different types of sedimentary rocks. Okay, so you will be able to state and explain the formation and characteristics of sedimentary rocks. Okay, you will be able to talk about limestone, sandstone, shale. These are the common examples, but there are many others as well. Coal is a very important sedimentary rock, even though it hasn't been specifically mentioned here. We will be learning about the formation of coal in chapter 2. Okay, so at that time we'll come back to it. Sedimentary rocks are formed by the compaction and cementation of sediments. These two words are really important. Okay, you will see it in the notes and do study that. Compaction and cementation of sediments. So I will talk about sediments. Okay, we will see that. Let's watch this video, and this one's talking about sedimentary rocks. Put the audio on.
Continuing math and science. In this video, let's take a look at sedimentary rock examples. Sedimentary rocks are formed from pre-existing rocks or pieces of once living organisms. They form from deposits that accumulate on the Earth's surface or under the ocean. These particles that form a sedimentary rock are called sediment and may be composed of minerals or once living matter called organic matter. Sedimentary rocks can be divided into several groups. Some common groups include clastic sedimentary rocks, which form from fragments of pre-existing rocks, chemical sedimentary rocks, which form by precipitation of minerals from water. Precipitation is when dissolved minerals come out of water. And organic sedimentary rocks, such as coal and limestone, which form from the accumulation of plant and animal debris. Clastic sedimentary rocks are subdividing according to the dominant particle size. These particle sizes are ranked from smallest to largest. Clay is the smallest, then silt, sand, gravel, pebble, and boulder. Up first is shale. Shale is a fine-grained, clastic sedimentary rock composed of mud. This mud is a mix of flakes of clay minerals and silt-sized particles of other minerals, especially quartz and calcite. Shale is very fine-grained. Next, let's look at sandstone. Sandstone is one of the most common types of sedimentary rock found throughout the world. It is a clastic sedimentary rock composed of sand-sized grains of mineral rock or even organic material. It also contains some cemented material that binds the sand grains together. And finally, limestone. Limestone is an organic sedimentary rock that is often composed of the skeleton fragments of marine organisms such as coral. About 10% of sedimentary rocks found on Earth are limestone.
These are all coming from other rock. So if you have, let's say, a piece of granite and it breaks down into these different sizes, you have all these things. It's the same granite, but it is big, you call it gravel. If it's a little smaller, then you call it sand, and so on. You understand? And soil is actually a mixture of all of it. When you dig up soil, you will see that it's never sand only, silt only, or clay only. Those always, it's a combination. But the percentage can change. The percentage of sand in sandy soil will be high, like on the beach. The percentage of silt, which is the tiny particles, will be more in farm soil, where you grow crops, farming. It's silt soil. And clay soil is very powderish. You will see it in rice fields, in the bottom of a pond, a buhera, so like that. So in some places you have clay, muddy soil. Yeah, so these are all sediments. But there are other living sediments as well. Okay, the living sediments are, well, not living, but formed from living, is seashells. Do you know seashells, right? You go to to the beach and you find seashells everywhere. Well, seashells are basically calcium carbonate, but it's produced by an animal. Like, in biology, you learn it as molluscans, right? Mollusca. So molluscans or snails and all these, shelled animals, mussels, they call it mussel. It's a shelled animal. They have these shells. And these shells, once the animal is dead, you got just the shell. And that is a sediment. And that sediment can make limestone. So if it is sand, it can become sandstone. If it is a shell, it becomes limestone. Now, if the sediments are sediments of trees, trees that lived millions of years ago, and they slowly become a sedimentary rock called coal. Okay, so it's depending on what sediment it is, you will have different sedimentary rocks. Okay, so what is a sediment? The definition says sediment is a naturally occurring material that is broken down by processes of weathering and erosion. So weathering is the breaking of rocks, erosion is when it moves due to the wind and water and everything. And it is then transported or moved, eroded by the action of wind, water or ice, or by the force of gravity, and you have the sediment moving usually to the sea. Now, let's say you have these sediments formed on the mountains. Now, this is a question to you, so listen carefully. So if you got these big mountains and the mountains are breaking down, the rocks are breaking down. Okay, that word is called weathering. Okay, it's due to weather. That's why the word weathering is used. Weathering comes from the word weather. Okay, so weathering, W-E-A-T-E-H-E-R-I-N-G. I'm just putting it into the chat. Weathering. This is the breaking down of rocks. Okay. Now, erosion is when it moves, when the broken down pieces, when it moves due to wind, water, ice, or gravity, we call it as erosion. Okay, that's a slight difference there. So my question to you is this: if you've got these rocks which are weathered, on the mountains, how will it reach the ocean? Okay, the process I mentioned, but literally, how will it go? How will that tiny bits and pieces of sand or silt or whatever, which is broken down by weathering, how will it reach the ocean? So it can be carried by water, near water bodies. That's good. Yeah. Can you name any? Which water body carries it to the sea? And your answer will be wind can carry it, but it usually doesn't reach all the way to the sea. Yeah, but wind is moving it. Of course, you're right. So wind pushes it into somewhere. Rivers and tributaries. Yes. See, what happens is that the rock breaks down and it will flow into rivers. It can be pushed by wind, of course, but rain, water and all that. And then rivers will carry it over into the ocean. And over there, they form layers. They pile up over each other. And when the sediments pile up over each other, over millions of years later, they all get compressed. That word is called compaction. Compact. Compaction means when something is pressed together. And it's usually by pressure, by weight. All the layers of sediments going one on top of the other. So I've just got a tissue box here. So I've got my phone there. So I've got these different layers of sediments piling up over each other. They get compacted, pressed down. But even if it's pressed down, they don't stick to each other, right? The particles may not be stuck to each other. And that's why we need the next step called cementation. Okay, so compaction and cementation are two words that you should not forget. And what gets compacted and cemented? Sediments. It could be any sediments. It could be sand, it could be silt, it could be clay, it could be a mixture of all. It could be seashells, it could be sediments of plant remains that lived long ago. All of these sediments can get compacted, pressed down together, and then they get glued together. That is the process called cementation. You know about cement, right? When we make a building, when we make the walls and everything, to keep it in place, we put cement. We mix cement and water and sand, and then we plaster the walls so that now the wall is really thick and hard, right? So cementation is that gluing process. Okay, and these are all done by minerals. We don't go and do this. We are not responsible for this. This is the whole process of physics and chemistry and everything together. So compaction and cementation of sediments. And based on this, you have three basic types of sedimentary rocks. It's nice to know these names, but if you feel like, oh, this is just too much, you can skip this. Okay, clastic or fragmental. Okay, fragments, when tiny bits, like I told you, sandstone. You've got a piece of granite. it broke down to sand particles. This sand particles goes to the seabed and forms layers, and it gets compacted and cemented together. It becomes sandstone. That is fragmental because it comes from fragments, pieces. Fragments means tiny pieces. The second one is called crystalline or chemical. It is formed by precipitation. Sometimes in a solution like place, when the water evaporates and all that, you may have them precipitating or combining together or forming crystals. Then you have example is a rock called rock salt. So this one is crystalline because it has this crystalline way of formation. The last one is probably more important or something very common. It's organic. It means that it's coming from something living or something that was living. Limestone and coal are both organic. They are formed by things that once was living, so it's called organic. Okay, so we'll see it more in detail. So this one here is fragmental. You can see three rocks here. One is called sandstone. The second one is called shale, which is sometimes can be called as clay. There is a rock called clay. There is a rock called shale. They're two different rocks. But clay particles are found in shale. And then you have siltstone, which is silt particles stuck together. Okay, they're different rocks. They are formed from different sediments. Sandstone is formed from sand. Siltstone is formed from silt. And shale is formed mainly by clay, but it could be other particles with it as well. They're all formed by fragments. So they're called clastic, and they're mechanically formed, pressed down, by weight. All the layers pile up on each other. They press down and form it. All right, so in this picture, you can see how that happens, right? You can see that in clastic or fragmental, you have the loose bits and pieces of rock coming off the cliff, right? And that's weathering. And then it's moving through the river, the stream, the river. It's getting transported by water. Sometimes wind blows it, so it's moving. Sometimes fast, sometimes very slow, but it's moving. And then it goes into the sea and it forms these deposits. And this is where it's going to, pile up on each other and then get compacted. Okay? I hope this is very clear to you. Weathering, it will loosen the quartz grain from the granite. So you got the granite piece, and then the quartz, which is the mineral in the granite, will become loose. That process is called weathering, breaking down of rocks. And then rain will move it, wash it. That's number two. Rain erodes the quartz. So this is called erosion. Erosion has mainly two processes: transportation and deposition. These are the main processes. So they will go from point A to point B, and then the stream will wash it. And finally, step number 4, the stream deposits the quartz grain on the beach. And there eventually it will form, it may go into the seabed, it may form layers, and you may have sandstone. So you have a rock produced in this way. Now, you will see fossils only in sedimentary rock. Okay, so what is a fossil? A fossil is remains of living things. Okay, remains of once living plants or animals. So here you have a fish fossil of a fish. You can see the fish, shape of the fish is, you can almost see the bones and everything. Well, this fish, unlucky one, died, we don't know how, but let's say it got buried under layers of mud. Maybe the fish just died and fell to the bottom of the sea, and then more mud came over it and it became compressed. But chances this could have been due to a big instantaneous result. Maybe there was a fish swimming in the sea, and then you had a large landslide, a collapse, maybe a big flood or something happened, and all of this material came and covered the fish and it pressed it down. And what happened was the fish, it's got that, how do I say it, the parts to it can be seen inside the rock now. So if you take a rock and you cut it open, you will see inside the rock these shapes. It could be the shape of, I have a fossil here, it is actually a plant fossil. So inside the rock you can see tiny leaves. So this is when the plant got buried under layers of mud and sand and everything, and then it got compressed. So fossils are remains of once living organisms, and you can find them only in sedimentary rock, not in igneous and metamorphic. I haven't taught you about metamorphic, but let me ask you this question. Can you imagine why you don't see fossils in igneous rocks? It's not a tough question. It's an easy question. You can type it in. Why you won't see any fossils in igneous rocks? You'd see them only in sedimentary. Why? Oh, I've got some answer here. It's because it is made from magma where it's too hot for fossils to exist. Yeah, that's the answer. It is too hot that even if there was any fossil that could have been there, it would just get burned away. Similar, metamorphic also, it's compressed and changed and all that. So the fossil, if it is there, will get destroyed completely. Okay, so igneous rocks, just because it's the magma, you won't see any fossils. Whereas metamorphic rocks, because the same rock, let's say I have that rock and I put it under high heat and pressure, it just sort of changes shape. And this fossil will completely get destroyed. So you won't see any fossils inside metamorphic rocks. The next thing is the word layering. You can see here layers of sediments, right? This rock is formed by different layers. So this structure, horizontal layering, is something you will see with sedimentary rocks. And sedimentary rocks are porous, and that's very important because these porous rocks are where we get our water from. These porous rocks are where we get our oil and gas. You know, in UAE and in Middle Eastern countries, that's our wealth, isn't it? The country gets money from oil and gas, and that is found inside rocks like sandstone. So porous rocks are extremely important for our, money and for our, activities. So if you want drinking water underground, thanks to a porous rock. It could be sandstone, it could be limestone, but thanks to one of the porous rock. Yeah. Do you have any questions? Is it all okay? So you have the fragmental rock. Now the processes or the stages I mentioned, generally for all these sedimentary rocks, for the fragmental ones, I should say, even for the organic ones, you have deposition. So usually in a calm place where the water movement is not much, it starts piling up. Again, it takes thousands of years for this process to happen. Okay, deposition itself will take thousands of years. So right now, deposition is happening somewhere in the ocean, it's continuously, material keeps coming in and gets deposited. It's coming from land, by the way. All the mountains that break down, the rivers carry it, and the sea gets deposited in a calm place. Second step is compaction. This is the most important part, okay? Compaction and cementation. So compaction is when pressure under all those layers will compact it. The rock gets pressed down. The third one is called cementation, when the particles are glued together, okay, by other minerals. So they become one piece. The thing about sedimentary rocks are, because it's formed in this way, they are not very heavy. They are also not very strong. So if you take a sedimentary rock and you take an igneous rock, the sedimentary rocks will be a little more lightweight, and also when you hit it, you can break it. So it's not very tough generally. Okay, so it's glued together, and you also see those layering and all that. Okay, the next one is formed chemically. When rocks are formed, sedimentary rocks are formed in a chemical way, and this is it forms these crystalline rocks. There are some limestone which is formed in this way, like calcium carbonate. It forms these precipitates and all that, and it may then later on harden together, so it may form limestone. This is not literally limestone from seashells. If it is from seashells, we call it as organic. Did you understand that? This is also limestone because it's calcium carbonate, but it's not formed in the same way like the other organic one. It's not formed from seashells. Okay, whereas rock salt is formed when all these things are crystallized. Okay, and so you have this. And this one has two processes here. One is precipitation and evaporation. Precipitation is when the mineral ions fall out of solution. Let's say you take a solution and it's fully saturated. Like, I take a small glass of water and I keep on putting salt into it. It gets to a point where you keep dissolving it. It can't dissolve any further, because it's fully saturated. And you leave it there, after a couple of days, you will see that the salt has sort of precipitated. The ions have sort of fall out. So a rock formed in that way is, formed by precipitation. You can see rock salt is a good example. And then you have evaporation. When the water turns into gas, water vapor, leaving the solids behind. So it was a solution, but the evaporation happened. Okay, so in precipitation, you don't have that evaporation. It's just precipitating out of solution because it's fully saturated. But evaporation is when, like, you got heat, and water is sort of heated by sunlight, sun's energy. So it gets evaporated, and what is left behind will be that solid, which turns into a rock. So limestone could be formed in this way. Okay, the common common sedimentary rock is organic or bioclastic. Bio means life. In other words, it's coming from living things. Yeah. So there are two main rocks here, coal and limestone. Coal formation we will learn later. But anyway, I'll mention it now. It's formed from dead plants, trees, okay, ferns, anything that lived like around 300 million years ago is now coal. Okay, so coal is formed over that time, 300 million years. And so that is organic sedimentary. If it is shells, seashells, corals, skeletons of animals, whatever, if they are formed in that way, it's cemented together, then you have limestone formed in a different way, organically formed. You can see, I've just put this picture for you to see how it, because that's not the way it is, but that's how it is formed. Here you can see one seashell. That seashell is not literally inside the rock, but that seashell gets powdered under pressure, and then it gets glued together. Can you imagine that? Don't imagine the seashell literally like a seashell inside the limestone. No, that's not it. That's not generally how it is found. Let's say in one place you've got thousands of seashells, because the animals were living there and then it died, so all the seashells remained over there. If you got more sediments piling over it, it gets compressed and turns into limestone. Like these cliffs, these are limestone cliffs. They are formed in this way millions of years ago. And you have to imagine that this is all happening underwater. But now you can see it's like above the water. How did that happen? This is called uplift. Rocks can get pushed up, or sometimes water moves away. Maybe this place was like flooded and with more water, and then it moved out. So that can happen. Or rocks can be pushed up and get exposed. So most of these rocks are formed in the seabed, where these seashells are found, and later on they get pushed up or whatever, due to plate movements. I'll teach you that later. And in the first picture, you can see coal formation. You can see swampy trees, and over time, gradually it's becoming coal. In one of these coming lessons, we will learn about coal formation. So that's just it. Just remember the sediments, okay? And they're forming sedimentary rocks, coal and limestone. Some of the uses of rocks, you can see sculptures. They're all good for sculptures because it's a rock that can be easily carved. You can carve it, it looks nice. But the also problem is that over time, these sculptures will become broken down because the rock is not very hard, you see. So the sculptures may be broken down after, let's say, thousands of years. So it can break down. Weathering can happen, chemical weathering, acid rain, it can eat away these rocks. So it is much more easier for weathering and erosion to happen. Okay, so we completed formation of sedimentary rocks.